Here is part 2 of our neutralization reaction lab. So the whole goal of this lab is to determine what is the concentration of the vinegar, and we're trying to detect whether it is a legal compound or not. Believe it or not, vinegar is regulated by the FDA, and it's used in a lot of pickling items, and so they need to make sure that the concentration is correct. Otherwise, the companies that rely upon the vinegar for their pickling, it might not work and it might not preserve their food samples. So let's take a look at what it is to be a neutral reaction or a neutralization reaction. If you can get a plain sheet of paper out and if you can write this information down. So neutralization, what is neutral? First of all, what is neutral? What pH do I have to be for it to be neutral? The pH has to be equal to 7. What does it mean to be neutral with respect to the concentration of acid and the concentration of base? We talked about this in lecture. Your acid is going to be equal to the concentration of base. So let me go ahead and just put this now in terms of English. The concentration of acid must equal the concentration of base. And what we're going to do is, from here on out, we're going to refer to the acid as A and the base as B, which makes this a little bit simple. So if my concentration of acid is equal to the concentration of base, that means the number of acid molecules is equal to the number of molecules of base. And if the number of molecules of acid is equal to the molecules of base, that means that my moles of acid will also equal the moles of base. Now, in the past chapters, we looked at this formula for molarity. So I'm going to remind you guys of molarity. Let's do it over here with this little triangle. Remember the molarity triangle. Capital M molarity is equal to moles over liters. So what will moles be equal to? Moles will then be equal to molarity times liters. So we can now apply this formula back up to here. And we're going to substitute in moles of acid and moles of base with molarity and liters. So my molarity of my acid, here's my capital M for my acid, times the liters of acid should equal the molarity of the base times the liters of the base. This is again just based upon the number of molecules of A should equal the molecules of B, the acid should equal the base, and we're now plugging in this formula from molarity. Well, we're trying to find out what is the concentration or what is the percentage of my acid, which is my vinegar. So we want to find out what is the concentration of vinegar. I can solve for that by dividing both sides by the liters of acid divided by the liters of acid. Those cancel out, and I'm left with this. The molarity of my acid, or my concentration of my vinegar, is going to be equal to whatever the concentration or molarity of the base is. And I didn't actually use liters, but if you remember, I used drops. It's going to be the drops of the base divided by the drops of the acid. So we need to do 3 things as part of our calculations. We need to determine the molarity of the base. We already know the drops of the base, but we need to calculate the average. And we already know the drops of the acid. Okay, if remember, we used the drops of the acid. This was our vinegar. This is what we started off with. So my drops of acid in each of my test tubes was 15. Okay, my drops of my base, I have the data right here. We have 32, 35, and 31. And if you take the average of that, the average drops of base is going to be equal to 32.67. So we have the drops of base, we have the drops of acid. We can calculate the molarity of the base by what we started with. So that's going to be step number one. We need to calculate the molarity of the base. So the molarity, going back to molarity, molarity is equal to moles over liters. So I need to have my moles of my base divided by the liters of the base. Okay, now we have a starting mass right here, and we used 0.43 grams. Grams is synonymous with moles, if you remember doing this on one of our handouts. So we had 0.43 grams of base of sodium hydroxide. This is the NaOH. This is what I had added, this is what I weighed into the 25 milliliters. So this is divided by 25 milliliters, and this was the water. Now, I need to get my grams into moles, and I need to get my milliliters into liters. So I need to do this. I need to cancel my milliliters and convert it into liters. 1 liter is equivalent to 1,000 milliliters. My milliliters will cancel, and now I'm left with units of this, of liters. But now I need to convert from grams to moles. So what I need to do is I have to cancel my grams, convert it into moles. 1 mole is equal to, how do I calculate the molar mass of NaOH? I have 1 Na, I have 1 O, and I have 1 H. Sodium is 23.0. Oxygen is 16.0. Hydrogen is 1.0. This adds up to be 40.0 grams. So this can go into over here at 40.0 grams. So again, we're trying to determine what's the concentration of my base that was inside my beaker. And if I take 0.43, multiply it by 1,000, divide it by 25 and 40, it's really interesting. This comes out to be equal to 0.43 molar. Now the number of grams actually equals the molarity of this, but that's only because I used exactly 25 milliliters and the molar mass is exactly 40. And when you multiply 25 by 40, you get 1,000, which cancels with that right there. So it's a unique case that it works out like this. So now I have 0.43 molar. That's the concentration of my base. And so I can now plug this back in up here, and then I can calculate the molarity of my acid. So again, we're trying to calculate the concentration of the acid by determining what's the concentration of the base that made it neutral. So I was previously in my acidic zone, and I added amount of base to make it neutral. Well, the amount of base to make it neutral is going to be equal to the concentration of the molarity of the acid or the vinegar. So let's plug it into that formula. We have 0.43 molar. Okay, this is the concentration of my base. The concentration of my acid will equal that times the drops of my base. The drops of my base is going to be 32.67 divided by the drops of my acid, which is 15. So I'm going to take 0.43 times 32.67 divided by 15. This gives me 0.93654, 0.94 molar. This is the concentration of my vinegar. Now, the question is this legal? Legal vinegar needs to be above 4%. So let's start with this again, and it is in terms of molarity. 0.94 molar. Well, if you remember the triangle, molarity is equal to moles over liters. So 0.94 molarity is equal to moles over liters. So it's equal to 0.94 moles over liters. Okay, and so what I want to get is I want to get to a percent from this. From moles over liters, I want to get to a percentage. And so what I need to do is I need to cancel my moles. I need to get them into grams. If you remember a percentage is the number of grams over 100 milliliters. It's the grams over 100. It's the parts per 100. So I need to get this into grams per milliliter. So if I have 0.94 moles over liters, I have 0.94 moles over 1,000 milliliters. I need to get my moles to grams. And the way to do that is I need to get my molar mass of vinegar. Vinegar is CH3COOH. So I have carbons, oxygens, and hydrogens. How many carbons do I have? 2. Oxygens, 2. Hydrogens, 4. Each carbon weighs a mass of 12. Each oxygen weighs 16. Each hydrogen weighs 1. 2 times 12 gives me 24.0. This gives me 32.0. This gives me 4.0. If you add 24, 32, and 4 together, you get 60.0 grams. So I want to cancel my moles and convert it into grams. So 1 mole of vinegar weighs 60.0 grams. So what's going to happen is my moles are going to cancel, and I'm going to be left with grams per milliliter. And I said an easy way to calculate the percentage is to take the mass divided by the volume of the solution and multiply by 100%. And if we do this, 0.94 times 60 times 100 divided by 1,000 equals 5.64%. This is greater than 4%, so my vinegar is legal. To summarize, we did a neutralization reaction where we got the pH to be from an acid to be neutral by adding the base. Well, when I am neutral, my acid is going to be equal to my base, and we knew that the moles is going to be equal to the moles of acid will equal the moles of base. We rearranged the molarity triangle to calculate the molarity in the liters to calculate the molarity of the acid so that we can gather the concentration. We already knew the drops of each, but we had to calculate the molarity using the grams that we added, which was, what was our grams that we added? It was 0.43 grams to 25 milliliters of water. From this, we calculated the molarity. From the molarity of the base, we then calculated the molarity of the acid, which is the vinegar. From the molarity of the vinegar, we then converted this from molarity into a percentage, and therefore our vinegar is legal.